right, so this problem tells us it's a word problem, so we kind of have to come up with what the words are telling us here. But Zachary is working 2 summer jobs, making $11 per hour lifeguarding, making $14 per hour clearing tables. In a given week, he can work no more than 17 total hours and must earn a minimum of $210. Also, he must work at most 14 hours clearing tables. If X represents the number of hours lifeguarding and Y represents the number of hours clearing tables, write and solve a system of inequalities graphically and determine one possible solution. So, and I've done a lot of the work here to get us going, but basically the top of each of these 3 columns here is the equation that we get, or the inequality, excuse me, that we get from the information in the problem. So like the first says, in a given week, he can work no more than 17 total hours. So X is the number of hours lifeguarding, Y is the number of hours clearing tables, X plus Y is the total number of hours, and it can be no more than 17, so it's less than or equal to 17. And then just to get it into a form that is more friendly on the graph, we subtract X from both sides and then rearrange it. So it's Y is less than or equal to negative X plus 17. And we'll see more about that when we get over to the graph, but that's what that one tells us. It says he must earn a minimum of $210. So $11 times X plus $14 times Y needs to be greater than or equal to 210. We want to earn a minimum of 210. So greater than 210 or equal satisfies that. And again, just to get it into a good form for us to be able to graph, we're going to subtract 11x from both sides, divide both sides by 14, which 210 divided by 14 is 15. And of course, 11 by 14 is 11/14. And again, we'll switch the order to just put that Y is greater than or equal to negative 11/14 X plus 15. Put that in that slope-intercept form. That's just so much easier to graph. And then that last one says he must work at most 14 hours clearing tables. So Y, the number of hours clearing tables, has to be less than or equal to 14. Anything above 14 is not going to satisfy that. All right, so those are our inequalities. We've got them set up. It says we want to solve them graphically. So as we go over to this other board here, we've got, what we did is we graphed equations only, not the inequalities. So really there should be shading on this graph. Unfortunately, it's not super friendly for that, but we're going to just draw some, draw the shading in ourselves. Basically, what it comes down to is that this blue line represents our X plus Y is less than or equal to 17, or in other words, Y less than or equal to negative X plus 17. So since it's less than or equal to, really the blue portion is everything that's below that line, right? And sorry about my horrible squiggling with a mouse pad here, but that's kind of how this one has to work. The green equation is our next one with the 11x plus, or not, yes, so the green is the equation form of 11x plus 14y equal to 10, but this is greater than or equal to, so y greater than or equal to negative 11/14x plus 15. So in other words, for our green, we want everything above that green line. And then again, with the pinkish looking one there, fuchsia maybe, whatever you want to call that, that's our y less than or equal to 14. So since it's less than, again, it's everything below that line. Now that we've made a horrible mess of our graph, what we're really looking for here is we're looking for an area that is overlapped by all 3 shaded areas. And what we'll end up seeing is that it is what just happened? That's not how that's supposed to work at all. Evidently, drawing a triangle isn't super helpful. All right, anyway, it's this triangular area in here. So, and because these are all less than or equal to or greater than or equal to, it's on those lines is fine as well, as long as it's the lines of that triangle. So since it wants us to give a possible solution, if I'm not mistaken, this point right there that is 512 is one possible solution. So if we said x equals 5 and y equals 12, and just to verify that, we can substitute that into all of these. So if x is 5 and y is 12, then 5 plus 12 is 17, so it's less than or equal to 17. If x is 5, then 11 times x is 55. Y is 12. 14 times 12 is 168. So 55 plus 168 is 213. Excuse me, 223. Doing that in my head. So, but it is greater than or equal to 210. And of course, y being 12 is less than or equal to 14. So that is one possible solution. So if you gave your answer as x equals 5, y equals 12, then this is in fact one possible solution for the system of inequalities represented on this graph. So anyway, hope that helps. Thanks.